So let's now find out the velocity components first for u velocity, then for v velocity. So for u1, as we already established, is delta psi, this is psi 1 per delta y, which is delta per delta y of q1 over 2 pi arctangent of y minus b1 over x minus a1, and the derivative of arctangent of x is 1 over 1 plus x squared. So in this case we have then q1 over 2 pi, we'll have 1 over 1 plus x squared, I'll write it separately, y minus b1 squared over x minus a1 squared times, and we have derivative of the argument itself per y, it's just going to be 1 over x minus a1. So when we work this out a little bit, we have q1 over 2 pi, and here we have x minus a1 squared, x minus a1 squared plus y minus b1 squared times this one here times still 1 over x minus a1. So this square and this term cancel out. We end up with q1 over 2 pi x minus a1 now goes in numerator, and we have x minus a1 squared plus y minus b1 squared in denominator. Now substitute here that q1 is 2 meters squared per second, a1 is 0, b1, these are meters, b1 is minus 1 meter, x is 1 meter, and y is 0. So when we substitute those, we get u1 equals 2 over 2 pi, here x is 1 minus 0, so we have 1 minus 0, divided by 1 minus 0 squared, plus y is 0 and b is minus 1, so it's 0 plus 1 squared, which boils down to 2 over pi equals to 0.159 meters per second. Now for the second source, which is positioned here at plus 1 minus 1, basically the whole expression is the same. We're just going to use the same derivative, just replace subscript 1 with subscript 2, so we can directly write that u2 is equal q2 over 2 pi, we'll just use this expression here, x minus a2 squared plus y minus b2 squared, because x minus a2, and when we plug numbers for that particular case from the table that we had before, the source is minus 1, as I said already, this is a sink really, over 2 pi times A2 now is also plus 1, so we have 1 minus 1, and here we have 1 minus 1 squared plus b is 0, y is 0, minus b is minus 1, so it's plus 1 squared, so, and that's equal to 0 meters per second. When you look back at the picture, you could anticipate that the influence on velocity here from this source, the u component in the x direction ought to be 0, because the velocity field is radially emanating from this point, so vertically above there's only going to be v component. And it also illustrates to you that we could sort of geometrically work out and say that the velocity component in u direction from this source would be basically, the total vector would be in this direction, and its strength would be the distance of the diagonal here, and then we would have components in u and v. So that's another way that you could have solved this problem. But here we're just going using sort of the template approach rather than resorting on some geometric shortcuts. Now for third component, u3, that's now a vortex at plus 1 position. And so we have delta psi 3 per delta y, which is delta per delta y up the square bracket here. So it's minus g3 vorticity intensity over 2 pi ln of r3, which is square root of x minus a3 squared plus y minus b3 squared. So when we work out the derivative, let's do that in a new line. It's going to be a longer expression here. So u3 is then, this is a constant, minus g3 over 2 pi. Sorry, this is equal sign and this is minus, over 2 pi. Derivative ln of x is 1 over x, so we have basically square root of x minus a3 squared plus y minus b3 squared in denominator, and then we need to work out the derivative of square root of this itself. So square root is x to the 1/2, so the derivative is really 1 over 2 square root. I'm going to put a little tiny expression here, plus y minus b3 squared, and then we need to get the derivative of the function under the square root, which in this case is 2y minus b3. So 2 and 2 are cancelling out, and we end up with minus g3 over 2 pi. These square roots are the same, so they multiply, so the square root disappears. We have x minus a3 squared plus y minus b3 squared in the denominator, and we're left with y minus b3 in numerator. Now we substitute the actual values here, and we have u3 equals minus 1.5 over 2 pi, that's g3 over 2 pi, and here we have y is 0 as everywhere else, b3 is plus 1, so it's minus 1 here, and here we have 1 minus 1 squared plus 0 minus 1 squared, which is 1.5 over 2 pi minus